Okay, so this is number 58 in your book on page 445. So let me make this, oops, a little bit bigger. And okay, so this is again on page 445 of your textbook. And so it says a company that manufactures bicycles. Whoops, let me get my arrow. A company that manufactures bicycles, right, has a fixed cost of $100,000, and it costs $100 to produce each bicycle. Now the selling price is $300 per bike. So in solving this exercise, right, let's let X represent the number of bicycles that are sold and or produced and sold, or sold and produced. So part A, excuse me, we want to write the cost function, right, of producing X bicycles. So very similar to example 9, right? It's on page 442. I'm looking at it right now. The yellow box, it says revenue and cost functions. So you have a definition for a cost function. So let's see, make that pink. So cost function is going to be C of X. Okay, it's very similar to our F of X, right? Our input, output, our function notation that we were talking about, right? Whoops. This is our F of X, right? Input, number of bicycles, right? Output is the cost of producing, X number of bicycles. And so the cost function is the fixed cost. Well, do we have a fixed cost? And we do, right? It's right there. So that's going to be $100,000. And it, according to our definition, right, the fixed cost is $100,000 plus the cost per unit produced times times X. So what is the cost per bicycle produced? And the cost per bicycle produced, right, the cost right here is $100. So that's going to be 100, well, times the number of bicycles, so that's just 100x. Okay, so this is our cost function, right? Notice that this is a linear equation, right? This is like y, well, it is really y equals mx plus b, right? Here's our slope, and this is our y-intercept. Okay, so the revenue function. Let's see, let's do the revenue blue. So write the revenue function, capital R, from the sales of X bicycles. So again, we have R of X, right? Input, and then we're going to find an output. So the price per unit sold. So the price per unit sold, well, here we're selling, right? And we're selling them, the selling price is $300 per bike. So that's just going to be $300, right, per bike. So that's really times X. So again, this is a linear function, right? This is really y equals mx, right? And the plus b, right, that's really a 0. So we know it's going to go through the origin. Okay, and then finally C. So here we want to determine the break-even point, okay? And after we find it, then we're going to describe what it actually means. Now, the break-even point geometrically is just going to be the intersection, right, of this line, whoops, that's not my arrow, of this line and this line, right? And it's going to be our x comma y. And well, okay, I'll talk about it after we have all our information. Okay, so we want the break-even point, so we need to write a system of linear equations. Well, we already have a system, right? Right here and right here. So let's see, I'll just stick with my colors here. Okay, so this is, well, let me go ahead and just write it out. So C of X equals 100,000 plus 100x, and R of X equals 300x. Okay, so I just wrote the same thing with the dollar signs, but this is my system of linear equations. Now, what I want you to remember is let's see, so I can have room here. Let me just, whoops, let me just make that a little bit smaller, just so I can, so this is your thinking or recall cloud. Remember that y is a function of x, right? Input, output. This notation, arrow, okay, here we go. This notation is very helpful because the F, right, can represent that revenue and the C can represent the cost. And Y is very generic, but when we're solving algebraically, we like using Y. So we're going to replace Y with R of X and Y with C of X. Okay, so let me, whoops, go back to, let me zoom in here. Okay, so we have this guy, right? That's really Y, and that's really Y, right? That's your output. So we really, again, we have Y equals 100, okay, I'll just leave it in black, 1,000 plus 100x, right? And we also have Y equals 300x. Okay, so there's my red and there's my blue. And this is, again, we know how to solve for x and y. Let me erase that. Where is my pointer? Here it is. So we know how to solve for x and y, right, by either substitution or elimination. I mean, or we can graph these guys. But let's do this algebraically. And I would use substitution just because y is already isolated and this y is also isolated. So technically, I mean, we can substitute, you know, excuse me, we can substitute this y, right, into this y, or this y into this y. Well, that really means we're just setting these guys equal to each other. So let's go ahead and do that. So I have 100,000 plus 100x equals 300x. And I'm actually going to stop here just because it's been 7 minutes, and I know when I upload these, they take a really long time the longer I go. So I will continue this in the next video. Okay, see you guys soon.